The Bible shows the way to go to heaven, not the way the heavens go, were the words of Galileo Galilei, who was ridiculed and threatened for his scientific discoveries that challenged the beliefs of the Catholic Church. Galileo is now one of the most lionized scientists in all history. During Galileo's time, the dominant Roman Catholic religion firmly believed in the philosopher Aristotle's theories. Aristotle created the idea of the geocentric theory, which asserted that the Earth is at the center of the universe. Galileo was directly challenging the Church by supporting the Copernican heliocentric theory, which contended the Sun, not the Earth, was the center of the universe.
Galileo will be told, formally, not to hold and defend the Copernican decision. It is stated that should Galileo refuse this order, he will be silent.
It wasn't until 1632 when he disobeyed the Church by publishing Dialogue Concerning the Two Chief World Systems. The book advocated the controversial heliocentric theory, a contrasting idea to what the community was ready to accept. Galileo inadvertently ended his scientific career with the publication when he was punished for heresy. Galileo Galilei challenged many of the commonly held beliefs of his time with his publication of findings on the heliocentric theory that opposed the Catholic Church, modernization of the scientific method, and inspiration to future scientists to eliminate scientific misconceptions. Galileo Galilei's publishings that supported the heliocentric theory contradicted the Catholic Church, which paved the way for major changes in the field of astronomy. If Galileo had not challenged the commonly held beliefs of his time, then today's society may not be as advanced in the field of astronomy. Interestingly enough, it was Galileo's most famous piece, Dialogue Concerning the Two Chief World Systems, that caused his conviction a year after the book's publication in 1632. Dialogue Concerning the Two Chief World Systems revolved around a fictitious argument that had arisen between two of Galileo's supporters and an imaginary character. Galileo used this fictional character, Simplicio, to represent Aristotle's ideas Galileo asserted to be false. Despite the Catholic Church's previous warning not to uphold the theory, there were multiple parts in Galileo's book which confirmed his support of the heliocentric theory.
At the very end, he puts the words of the Pope in the mouth of the simpleton, that if God wanted to make the universe some other way, any other way, but make it appear to us the way it does now, he could have. And therefore, none of these arguments about whether the sun is the center or whether the earth is the center can be definitive.
Afraid of what it might spur, the Catholic Church banned the book, and Galileo was called to the Inquisition. The Inquisition did not approve of Galileo's pleas, and as a result he was charged for heresy. Yet despite his conviction for heresy, history has judged his right to seek after truth quite differently. According to legend, as Galileo signed his recantation following his trial, he mumbled, "Eper si mueve," and yet it, earth moves. Although Galileo never spoke these words, the legend's existence and endurance is a fitting indication of the eventual support he received not only for his work, but also for the right of the scientist to engage in free and open inquiry. Following his trial, Galileo's works were put on the Index of Forbidden Books, which were not taken off the list until the early 1800s. However, if Galileo had not challenged the Church in the first place, many scientific assumptions of his time would have carried on into now. Galileo's works marked a turning point in scientific and philosophical thought and changed how we view astronomy today. As a result, the restriction the Catholic Church used to prevent Galileo Galilei from popularizing the heliocentric theory during his lifetime left his breakthrough publishings as guides for future astronomical advancement. Through his experimentation and modernization of the scientific method, Galileo greatly influenced how scientific phenomena was explained. Without Galileo's revolutionary experimentation, today's world would lack the scientifically supported ideas essential for the human race's advancement. Galileo's fame not only lay in his development of the scientific method, but in how his methods defied the common beliefs of his time. It was through trial and error in which Galileo was able to conduct experiments that challenged the philosophical ideas of Aristotle and answered the questions he sought the answer to. It is believed that at the age of 19 in the Cathedral of Pisa, he timed the oscillations of a swinging lamp by means of his pulse beats and found the time for each swing to be the same no matter what the amplitude of the oscillation, which he verified by experiment. As a result of Galileo's influence, science and mathematics began to be more widely accepted than philosophy when used to explain phenomena. Today, it is hard for anyone to comprehend that there was a time where claims were not researched scientifically. Galileo developed a more modern concept of researching, which scientists still use today. In consequence to Galileo's unique experimentation, the value of science and mathematics would forevermore be of great importance to all scientists. In addition to Galileo Galilei's mathematical accomplishment, Galileo also inspired other scientists and sparked a revolution of scientific achievement. Without the influences of Galileo, today's society would not be as technologically advanced. Curiously, Sir Isaac Newton, one of the most admired physicists and astronomers of all time, was impacted by the discoveries of Galileo. Newton was a scientist that lived from the 1600s to 1700s, for not long after Galileo's death. Newton's most recognized achievements today are his three laws of motion and his alteration of the telescope, both of which were inspired by Galileo. Before Newton's time, Galileo had discovered a piece of the laws of motion during his lifetime. Known as the law of inertia, Galileo unearthed how any mass in the field of Earth's gravitation, untouched by another mass, would move in a straight route. Galileo also figured out how a downward-falling object in Earth's gravitation would increasingly pick up velocity. These discoveries made by Galileo perfectly relate to Sir Isaac Newton's three laws of motion, which help explain the phenomenon of how an external force can increase the velocity of a falling body. In addition to these laws of physics, Newton followed where Galileo left off and made a bigger and better telescope, once again expanding our view of our galaxy. Sir Isaac Newton's adaptation of Galileo's telescope included optic lenses which refracted the light of an image, instantly magnifying it. Following this invention, Newton continued with his study of optics and created the theory including the lens later. Galileo made an obvious impact on Sir Isaac Newton, but he also influenced the creation of the lesser-known Herschel Space Observatory and Hubble Space Telescope. Both revolutionary, these Earth-orbiting telescopes were released in the more recent years of 1990 and 2009 to scour the infinity of the universe. Although the Herschel telescope ran out of gas in 2013, it still gave us a great deal of knowledge about our Milky Way galaxy, and the Hubble Space Telescope remains in orbit today. Without the help of these much improved adaptations of Galileo's telescope, we would be unaware of many things beyond the Milky Way galaxy. Most of today's most significant astronomical inventions can be traced back to Galileo, who truly advanced our world to the place we are today. Galileo Galilei challenged many of the commonly held beliefs of his time with his publication of findings on the heliocentric theory that opposed the Catholic Church, modernization of the scientific method, and inspiration to future scientists to eliminate scientific misconceptions. Galileo's challenge against the Catholic Church significantly impacted how astronomy would be researched in the future, for without it, astronomers would not have been inspired to eliminate scientific misconceptions through creation and confrontation. Sir Isaac Newton introduced his three laws of motion explaining the forces of gravity, and his theory of optics which changed how the skies were previously perceived. Then again, as recent as 1990, the Hubble Space Telescope was released above the Earth's atmosphere and marked an important point in the history of the telescope. In the more recent year of 2009, the Herschel Space Observatory was launched to orbit around the Earth. The Herschel Space Observatory's expedition ended in 2013 due to it running out of resources, yet it still played an important role in expanding our knowledge of the solar system. Despite Galileo's ups and downs, his contributions to astronomy, modernization of the telescope, and accurately supported confrontation with the Catholic Church truly factored in to how advanced our society is today.